Good afternoon, everyone. My name is Petteri Kivimäki. I'm the CTO of Nordic Institute for Interoperability Solutions, NIS for short, and today I'm here to tell you about data spaces. But before diving into the topic, a little bit of background so that you know, well, where I'm coming from and first of all, why I am interested in this topic. And so first of all, about NIS. NIS is a non-profit association that was established in 2017. Our mission is to develop digital government solutions to our members, and currently we have 3 members, the governments of Estonia, Finland and Iceland. And yeah, we are a non-profit association. And like I said, we were established in, well, here it's 2018 when we became operational, and after that we have been we've started to develop our main product X-Road and our secondary product Harmony e-delivery access, which are both open source solutions for secure data exchange. So everything that we do is basically open source. We started to look into data spaces around 5 years ago. Back then it was a new, interesting data exchange concept, and since our products, they are about secure data exchange, of course, we were interested in learning more about it. Well, since then we've got involved in several different data space initiatives. If you are familiar with the concept, you've probably heard about GaiaX, International Data Spaces Association, the Data Spaces Support Center. We are involved in all of them, and if you are not familiar with them, that doesn't matter, because after this presentation you will be. Then very shortly about X-Road, which is our main product, an open source data exchange solution. And it's not a new solution. It was originally, the first version was originally published over 20 years ago in 2001, and it was open sourced in 2016. Today there are 28 X-Road ecosystems around the world, and as you can see, X-Road is truly an international solution. And the reason why I'm sharing this background regarding X-Road is that today X-Road, when it comes to how it works, it's very similar to the data space concept. However, it's not a data space technology, but right now we are working on transforming it into a data space technology. So in case you are working with some existing data exchange technology, it might be interesting background information also for you, that not all the data space initiatives and products are necessarily new, but it's also possible to transform existing technologies into data spaces as well. But yeah, now to the actual topic. So here I have listed several data exchange solutions, standard specifications and even regulations from the recent years. The data space concept is not going to replace any of these, but it will rather provide a new way to use them together. I will take this off. Sorry about that. But yeah, so the data space concept will rather provide a new way to use these different technologies and solutions together in a new, more interoperable way. The data space concept, it's not about technology, it's more about interoperability. The European Interoperability Framework defines 4 layers of interoperability, which are technical, semantic, organizational, and legal. when we software engineers talk about interoperability, we usually talk about technical interoperability, which of course is important. But when thinking about interoperability on a wider scale, of course, we need to have all these different layers of interoperability, and the data space concept is about all of them. So what is a data space? If you Google the term, you will find many different definitions. There are multiple data space initiatives that all have their own glossary, and they have their own definition what is a data space. The definition that I have taken here, it's probably the most adopted one by the data space is support center. But what is a data space in more practical terms? So first of all, a data space supports multiple use cases. So it's not only for some specific business domain or some specific use case. So it's a generic concept. It's based on distributed architecture, and it's governed by a governance framework that defines different aspects of a data space. More about them a little bit later. Then a data space enables trusted data transactions, and it enables data sovereignty. At the same time, it's also good to understand what a data space is not. So it's not a data lake or a data warehouse. It's not a new data exchange protocol either. Protocols are closely related to the data space concept, but on a different level. And I will discuss more about the protocols just a little bit later. And then a data space is not only a data platform, and it's not only a technical solution to exchange data either. When we look at the history of data exchange, so first we have a bilateral data exchange between just two parties, and then we have a few-to-few data exchange within a closed community data sharing. The common factor between these two approaches is that, well, the number of organizations or parties exchanging data was small. They all know each other, and they all trusted each other. But nowadays, we are already in this decentralized ecosystem situation where we have many type of data exchange. And the challenge is that different data exchange parties don't know each other, and of course they don't trust each other either, since they don't know each other. And if you want to exchange data with another organization, of course, trust plays a very important role. And one important question that the data space concept is trying to answer is how to establish trust between different parties. Well, if we think about an existing data ecosystem, and then how would you build a data space between its participants? So let's assume that we have within an existing data ecosystem a group of participants that have a specific use case, and they want to deepen their collaboration regarding that use case. So they decide to kick off a data space initiative. So they start to define the rules and policies of the data space, roles and responsibilities, technical standards that you need to implement in order to be interoperable, and all these things they form the governance framework of the data space. So basically the rule set, rules and policies that the data space participants must follow. And then in practice, when they have defined these rules, they have the governance framework, then it needs to be operationalized in order to have the data space actually up and running. So depending on their governance model, whether they have decided to have one or multiple governance authorities, well, at least one, there is one governance authority that will be responsible for maintaining the governance framework. Then we have the participant organizations that need to deploy technical infrastructure that implements the technical specifications defined by the governance framework. And in that way, then they can start to exchange data with each other. And depending on the governance framework, potentially new members may join the data space later. But to simplify the process, how to set up a new data space, these are basically the three steps. And here is a conceptual model that basically describes exactly the same things that I just explained, just presented in a little bit differently. When it comes to the different roles in data spaces, well, a few of them were already mentioned. So first we have a participant, which is a member organization of a data space that either consumes or provides data or services to other participants. Then we have operators and intermediaries. They are organizations that provide participants with data space enabling services, and those can be technical services like service catalog, monitoring services, audit services, and so on, or business and organizational services. The difference between operator and intermediary is that if there is only one organization providing all these enabling services, then it's usually called operator. Instead, if there are multiple services, multiple organizations providing the services, then they are called intermediaries. And then very important role, trust service provider who issue credentials to participants that validates and verifies conformity of participants. And then finally, the governance authority that maintains and governs the governance framework that defines all the rules and policies of the ecosystem. And there are different governance models a data space can have. Well, probably the most common one is a centralized governance, where we have one governance authority, but there could also be multiple governance authorities when we are talking about federated or distributed governance. And I know that there are some data spaces also with the decentralized data space governance, and in practice it means that usually in those cases the data space is utilizing smart contracts stored on a distributed ledger so that the members or participants of the data space can vote on things that require decision making. But that's at least currently definitely the less used option between these three. Then when you start building a new data space, you definitely don't need to start from scratch. There are a lot of building blocks available. Usually building blocks are considered technical ones, but in this case there are also business and organizational building blocks available under different categories. So there is a lot of material available. Maybe one challenge with these building blocks might be that some of them they work nicely together. They are kind of interoperable, but then there are also building blocks that might not play so nicely together. So you shouldn't just consider that if I take these 5 building blocks, they all play nicely together. They might, but not necessarily always. So a little bit background studying is needed. And of course, the situation regarding the interoperability, it's improving all the time. This is a technical illustration of a data space. Like I mentioned before, it's based on a distributed or decentralized structure. So the main idea is that, well, you could say that the data space concept is based on a so-called four-corner model, which idea is that data exchange parties are not communicating directly, but instead they communicate through standardized access points. And in this diagram, those access points, they are called participant agent. So they implement specific standards and specifications which makes them interoperable. They provide out of the box certain features enabling secure data exchange. But then overall there are also other components, the so-called enabling services, service catalog, database registry, vocabulary hub, and so on. But the main idea is that data is always exchanged directly between the two participants. So there is no centralized message broker or anything. And then when it comes to the participant agent component, it's, well, maybe in a sense the most essential one because every participant needs to have it. Currently, it still has multiple names. I mean, different data space initiatives are using different terms when they are talking about it. Here, it's participant agent. And this is another diagram by a different data space initiative describing exactly the same thing, but as you can see, with different terms. Here the participant agent is called IDS connector. But fortunately, this terminology is currently being standardized, so the situation is improving, and the participant agent IDS connector, it is called nowadays data space connector, and it's the standardized term. But still, if you go to look for information about data spaces, it's highly likely that you find these diagrams with well, sometimes with almost the same terms, with the same meaning, but sometimes there can be same terms with different meanings. But the situation is improving. And yeah, then the interoperability Blight mentioned it. It's based on, of course, standards and specifications. And on a more detailed level, the data space protocol stack consists of 3 different layers: trust plane, control plane, and data plane. The trust plane is about identity management and trust management. The control plane enables service discovery and contract negotiation, and then the data plane is about the actual data transfer over the wire. And the trust plane and control plane layers, they are standardized. So there are data space specific standards that define how they should be implemented. But then on the data plane level, the idea is to use existing data exchange protocols and products. Like I mentioned before, the data space concept is not a new data exchange protocol. So this is what I meant by it. So the top 2 layers, they provide interoperability regarding trust, service discovery, and contract negotiation mechanisms. but then the actual data exchange takes place using existing standards and technologies. When it comes to standardization activities, there is a lot going on right now. Some of the standards, they are European, while others are international. Some of them are open source, while others are like more generic ICT technical specifications. And some of the standards, they are really data space specific, while others are more common IT standards, like for example, decentralized identifiers and verified credentials. They are not data space specific, but they are utilized in the implementation. Here is a list of some of the data space specific standards that are currently being developed. The Eclipse data space working group is steering the work, and there are also new standards coming up. So things are developing quickly right now. When it comes to different data space initiatives, they can be divided into 3 different categories. The first category is data space initiatives that are creating specifications and building blocks, like technical specifications, reference architectures, playbooks, and so on. For example, International Data Spaces Association, IDSA, Gaia-X, FIWARE, they are examples of these kind of initiatives. Then the second category is the initiatives that are implementing technical components based on these specifications. Most of them are open source, but there are also some proprietary and commercial solutions as well. For example, the Eclipse data space components, Gaia-X, FIWARE, they are examples of organizations falling under this category. And as you can see, there are organizations that are part of the number 1 and number 2 category. It just means that they define specifications, but they also implement components that are compliant with those specifications. And then finally, third category, that is by far the biggest one. So the initiatives that are actually implementing data spaces regarding real use cases. So we have the common European data spaces and then other data space initiatives. Now, when it comes to the kind of regulatory foundation of data spaces in Europe, there are several different regulations that are affecting the implementation. There is the strategy for data that kind of sets the foundation of data space related work and also some of the regulations. So we have the European Strategy for Data, and it's operationalized by the Data Governance Act and Data Act. And in Data Act, there is an article, I think it's Article 33, that defines direct requirements for data spaces. And then there are organizations that are facilitating the implementation of data spaces in Europe. The Data Spaces Support Center. They are not defining, they are not creating new standards or specifications, but they are supporting the existing activities, and they are, for example, publishing the data spaces blueprint that is a very good information regarding data spaces. If you are looking for more information about them. But then there are also a lot of other regulations that may have an impact on data spaces.
And by this I mean that it depends on the data space and what kind of, first of all, what kind of data you are exchanging. Is it personal data, non-personal data? Then what type of organizations are involved? Are they public sector organizations, private companies? And also where they are located, in which country, and what is the sector? Is there maybe some sector specific legislation? So this doesn't mean that all these regulations they affect all the data spaces, but if you are considering setting up a data space, you should probably consider these different aspects that I mentioned, and based on that, then evaluate what laws and regulations might affect in the implementation. Unfortunately, there is no like simple answer to that. But then, a few words about common European data spaces. So they were already included in a couple of slides before. So they are derived from the European Strategy for Data. They are, like 14 high impact data sets from the public sector. The European Commission is supporting their implementation. But then, besides the common European data spaces, there is a huge number of other ongoing data space initiatives from the private sector, public sector, very different type of data spaces. The International Data Spaces Association has published the Data Spaces Radar. It hasn't been updated recently. I think last update was last year, but already then it included like 150 different data space initiatives. And today the number is even higher. And here I wanted to include a couple of example data spaces. So the first one is Catena X. This one is maybe the most mature one. It's fully operational. So it's about automotive industry. For automotive manufacturers and suppliers, dealer association, equipment suppliers, the whole supply chain. And there are some pretty big European automotive industry players included. This data space as a whole, it's not limited only in Europe. As you can imagine, automotive supply chain is international. There are companies involved all around the world, so also the data space is really international. Another example is EONAX, a little bit different one. So this is a cross-sector data space focused on mobility, transport and tourism. There are use cases from different sectors. I have listed a couple of use cases here, these are links where you can find additional information about them. But then at the end, a couple of conclusions. So first, interoperability. It's not only about technology. The other layers of the interoperability, they play an important role too and shouldn't be forgotten. Then data spaces, they play an important role when it comes to data exchange across borders and business domains, and also within borders. So regardless of the type of the data exchange, data space, they have an important role. But at the same time, they are not the only data exchange concept, and I'm not trying to say that, hey, now data spaces will replace all the other existing concepts. That won't be the case. So there will be other concepts and ways to exchange data in the future as well. And technical convergence, it's very important so that we gain interoperability. The last thing that we want to do is to build new data sharing silos. And in order to enable interoperability, we need international standards and specifications. But of course, then they also need to be adopted. It doesn't help a lot if we have them, but no one is using them. And last but not least, common European data spaces and other data spaces. So it's good to remember that common European data spaces, yes, they are data space initiatives, but then at the same time, not all the data spaces are common European data spaces, so there is a difference there. And finally, I have collected here some links for you if you are interested in learning more about the data space concept. I think these resources are a very good starting point. And of course, if you have questions for me, you want to contact me after the presentation, here's my contact information. I'm always happy to talk about data spaces or X-Road or whatever related to technology. So thank you very much for listening. And yeah, do we have any questions here? Let's see the chat. There's nothing in the chat. How about here? No questions. Okay, in that case, thank you again for coming, and have a nice rest of the conference, and please don't forget to give feedback. Thank you.